Did human beings actually evolve from monkeys, or is it just a theory? A question that has sparked countless debates and discussions. It's a question that has lived in the corners of our minds, often surfacing at the most unexpected moments. But before we dive into this intriguing topic, let's dust off a common misconception that has somehow managed to stick around. We didn't swing down from the trees, shedding our tails and monkey fur to walk upright as humans. That's not how evolution works. The truth is, we humans share a common ancestor with monkeys and apes. We didn't evolve from them, but alongside them. We're like distant cousins in the vast, interconnected family tree of life. So, the next time you ponder about our origins, remember, we are not descendants of monkeys, but rather, we share a common heritage. Let's delve deeper into the fascinating world of evolution, shall we? Evolution, in simple terms, refers to the process of change in all forms of life over generations. It's like an awe-inspiring slow-motion movie of life's history, with each frame representing a tiny step in the grand journey of life forms adapting and changing over time. At the heart of evolution is the principle of natural selection. This principle was first articulated by Charles Darwin in the mid-19th century. Imagine a population of creatures, each with its unique traits. Some of these traits may give certain individuals an advantage in surviving and reproducing. Over time, these advantageous traits become more common in the population, leading to a change in the species as a whole. This, in essence, is natural selection. Now, where do these variations come from? The answer lies in our genes. Genes are like the instruction manuals for building and operating an organism. They are passed down from parents to offspring, but sometimes there are tiny errors or changes in these instructions known as mutations. Most mutations are neutral or even harmful, but occasionally, a mutation can provide a new trait that gives an individual an edge in the survival game. When such beneficial mutations occur, they can be passed on to the next generation. Over countless generations, these small genetic changes can accumulate, leading to significant differences in a species. This is how new species can evolve from a common ancestor. It's important to note that evolution doesn't work towards a predetermined goal or create perfect organisms. Instead, it's a continuous process of adaptation to changing environments, driven by the simple yet powerful mechanism of natural selection. This process of natural selection has been shaping life on Earth for billions of years. From the tiniest microorganisms to the largest mammals, every living creature is a product of this grand, ongoing evolutionary journey. So, when we talk about human evolution, we're really just exploring one chapter in this vast, complex story of life. One of the most common misconceptions is that humans evolved from monkeys. This, however, is not accurate. So, let's clarify this once and for all. When we talk about evolution, we're not suggesting a linear progression from one species to another. Instead, think of it as a branching tree, where each branch represents a different species. Over time, some branches end, while new ones sprout, each one unique yet interconnected. Here's where the concept of common ancestry comes into play. Humans and modern apes like chimpanzees and gorillas didn't evolve from each other. Instead, we all share a common ancestor, a species that existed millions of years ago. This ancestor was neither a human nor a modern ape, but a different species altogether. Over time, various factors like genetic mutation, natural selection, and environmental changes led to the emergence of different species from this common ancestor. Think of it like a family tree. You and your cousin didn't evolve from each other. You both evolved separately but share a common grandparent. Similarly, humans and modern apes evolved along different lines, but we share a common grandparent species. Moreover, it's important to remember that evolution is not about upgrading or improving species. It's about adaptation and survival. Species evolve characteristics that help them survive and reproduce in their environment. It's not a ladder of progress where humans are on top, but a complex web of life where every species plays a critical role. So when you look at a monkey or a chimpanzee, know that they're not our ancestors or our inferior versions. They're our distant cousins, each with their own unique evolutionary journey. They're not stuck in time while we moved ahead. They too have evolved, just in different directions. So, no, humans did not evolve from monkeys, but we do share a common ancestor. It's a subtle distinction, but one that makes a world of difference in understanding the fascinating process of evolution. The theory of evolution is not just a theory. It's backed by a plethora of scientific evidence. Let's dive into some of the compelling types of evidence that support this theory. Firstly, we have the fossil records. When we look at the layers of the Earth's crust, we find different species preserved in these layers. The deeper we go, the older the fossils. This clearly shows a progression of life forms over time, from simpler to more complex. Dinosaurs didn't just pop into existence, and neither did we. There's a clear trail of transitional fossils that link different species across ages. Then, there's genetic evidence. With advancements in technology, we can now compare the DNA of different species. It's fascinating to find that humans share more than 98% of their DNA with chimpanzees. But it's not just about apes and humans. All life on Earth shares a common genetic language, suggesting a single common origin. This genetic similarity across species is a strong indicator of common ancestry and evolution. Lastly, let's talk about observed evolutionary changes. Evolution isn't just a thing of the past, it's happening right now, all around us. Scientists have documented numerous instances of evolutionary change in the wild. From the peppered moth in England, which changed color during the Industrial Revolution, to the famous Darwin's finches in the Galapagos Islands, whose beak shapes evolved over time in response to the type of food available. Each of these types of evidence, from fossil records to genetics to observed changes, serves as a pillar supporting the theory of evolution. They aren't isolated pieces of a puzzle, they interlock perfectly, each one complementing and reinforcing the others. Together, they present a compelling, comprehensive picture of life's history and continual transformation on Earth. Each piece of evidence corroborates the theory of evolution, painting a comprehensive picture of life's history on Earth. Understanding evolution is crucial, but why does it matter, you may wonder? Well, the implications of understanding evolution are far-reaching, from medicine to conservation, and even to our understanding of our place in the natural world. Let's start with medicine. Evolution is at the core of many medical breakthroughs. Understanding evolution allows us to understand why certain diseases develop and how they can be treated. For instance, the development of drug-resistant bacteria is a direct result of evolutionary principles. Bacteria evolved to survive in the presence of antibiotics, leading to new strains that are resistant to standard treatments. By understanding this, we can develop strategies to combat drug resistance. Next, let's talk about conservation. Evolution provides a framework for understanding biodiversity. By understanding how species have evolved and adapted to their environments, we can make informed decisions about conservation efforts. For example, knowing that a certain species of fish has evolved to survive in a specific type of freshwater environment can guide efforts to protect that habitat. Without an understanding of evolution, these efforts could be misguided or even harmful. Lastly, evolution helps us understand our place in the natural world. It teaches us that we are not separate from nature, but a part of it. We're the result of billions of years of evolutionary processes, just like every other living organism on this planet. This perspective can foster a sense of responsibility towards our environment and other species, reminding us that our actions have consequences that ripple through the web of life. In the grand scheme of things, understanding evolution allows us to appreciate the complexity and beauty of life. It reminds us of our interconnectedness with all living things, and underscores the importance of preserving the delicate balance of our ecosystems. So why does understanding evolution matter? Because it helps us navigate our world with a deeper sense of awareness and responsibility. It informs our actions, from the medical treatments we develop to the conservation efforts we undertake. It broadens our perspective, reminding us that we are part of a vast, intricate web of life that has been evolving for billions of years. Evolution, in essence, helps us understand the past, inform the present, and predict the future. So, to sum it up, evolution is not just a theory but a comprehensive scientific explanation that's backed by a wealth of evidence. It's the process by which species change over time, adapting to their environments in ways that enhance their chances of survival. One common misconception is that humans evolved directly from monkeys. That's not quite right. Instead, we share a common ancestor with modern apes, and we've all been evolving in our own directions since that divergence millions of years ago. The evidence supporting evolution is substantial and comes from diverse fields like paleontology, genetics, and comparative anatomy. And why does this matter? Because understanding evolution helps us grasp the interconnectedness of all life on Earth, and it's critical to many aspects of modern science and medicine. Remember, we didn't evolve from monkeys, but we're all part of the same tree of life. That's evolution for you.